Hey, what's up, everybody? I'm just doing a live stream real quick to put forth the expansion of my 123 to the 134 circuitry that I'm using right here. So I'm charging two batteries uh, independently per coil. I'm using batteries to charge batteries right now, but I'm thinking about hooking up a relay and having it run like that, having it run like a relay. So you basically have one base connection, three collector connections, and four emitter connections, and one diode. This is a resistance list except for the light bulb. There's no resistance in this circuit. I don't know if that's good or bad, but that's where we are right now in its expansion. And it works pretty good. I mean, these batteries are both charging. Look at the tiny coils I'm using. And I mean, it's all working pretty well right now. Now, if you take your time and you read this, this makes sense. 100% makes sense. If you connect the dots one at a time, you can read this. Me doing it on a computer or something isn't going to make it look any better. I mean, that's how I would draw it, even on a computer. So like from a dot, you got your bridge over to the connection. It's really straightforward. And it's the best I can do right now. So I'm sorry. But not really. I mean, I enjoy drawing them. For those of you that can read it, thumbs up. So it's basically a 1, 2, 3 circuit that can charge a battery. Yes, and it can run a motor. It can do anything you want it to. And these are all on, excuse me, my throat is just tore up. Here we go. All right, so this is the 134 circuit. This can charge a battery, this can run another motor. It's really similar to a Bedini circuit. However, there's only the light bulb for resistances. There's no resistors. You could put one in there, but we're not there yet. I mean, this circuit is evolving from 123 to 134. So you turn on each one and they each charge their own battery currently. But I'm planning on making it a relay. And honestly, I would, draw this up on a computer, but I got just as many complaints about that. So I just decided to draw it. And it is compact. It is close together, but I tried to space it out as much as I could. You got your primary battery here. You got your charge battery here. You got your diode coming off the collector to your charge battery. You got everything grounded on the emitter. You got your out to your coil on your emitter too. And then the other end of your coil is grounded to your primary battery. So that becomes a common ground, your emitter. Um, it's the collector. You got your positive of your battery going to your collector. You got your lights hooked up to your emitter and your collector. So this is all light right here in the middle. And then your trigger is grounded. Your battery is grounded. Charge battery, that is. So now you got 4, 3, and 1. And it's pretty awesome. Hello. How you doing, Megan? So I think it's pretty cool that these little coils right here are charging these big batteries over here. Just using, well, I'm using these 12 volts to charge those 12 volts, but I'm planning on making it a relay and having the battery swap because the coils are in a perfect position with the 180 rotor to relay without relays. So that's good. The Bedini bounce. Although I'm not using the Bedini circuit, I'm still going to give credit. The Bedini bounce. There was an extreme voltage drop the last time I tried doing it, so I'm just going to hold off for a little second on doing it again. But it's real simple. It's just that I have to change a couple connections and connect the input battery to those batteries over there. These batteries. See, those are the ones that I'm charging right now. You know what? I'm going to carry the phone because it's just all over the table. So then we can get some angle shots of the multimeters. So this is the 134. Charging some batteries here. Now this meter is dead, but we're gonna get a reading real quick. 12.9. Awesome. That's the battery that bled out too. So this is the circuit that I had over there on the paper. This is the addition part right here. This diode. And then it's grounded on this one to the emitter. So you just add one to both the collector and the emitter. Heck yeah, man. I'm going to turn this into a relay. So it's basically, this is it right here. Here's your transistor. There's all the connections you have to your transistor via breadboard, PCB, or whatever, what have you. It doesn't matter. These are the connections you have to your transistor, and it's pretty clear, I think. Everywhere where there's a dot, you follow that line, and it connects somewhere. There's only one. There's two elements in this besides the transistor. There's a light bulb, which can either be a neon or a halogen, anywhere from 90 to 120 volts. It's good if it has filament on the inside, added resistance, and your diode. And that's it. Now we might add resistance in the future, but I need to work with some pots and stuff like that. I'm just taking it a step at a time. Right now, we're charging two batteries. And I tested the coils, and their cost is very inexpensive. See, excuse me, I'm running them on batteries right now. Now it's like, you can make fun of the table, you can make fun of the drawing, that's all good. If you make fun of my voice, I'm gonna have to scream at you. It's been a hell of a ride, you know what I mean? It's been really hard losing your voice, basically. When you got so much to say, it's like, yeah, mean joke. So look, that's charging at a pretty rapid pace considering how tiny that coil is. And I don't know, man. I think this is a win-win. I could go relay with this with how inexpensive it is to run. Because it charges pretty quickly. Let's see. Still at 9.2. It's not going to show. That's unfortunate. I could probably swap them. Swap the output of the multimeters. Or when I mean swap the multimeters. All right, so excuse me. This is the 134. It's an expansion of the 123. You just add a connection to the collector and the emitter. You got your primary battery, your charge battery. So your positive side of the battery is always going to be connected to the collector or the coil before the collector. I apologize. Man, I thought my throat would be all right, but we'll manage though, I hope. Yeah, pretty straightforward. You got your base, which is your trigger, Comes down here, connects to the trigger. The other end of the trigger gets bridged over that and goes up, another bridge, and connects to the emitter for grounding. So I mean, yeah, that's it right there. And you're looking for resistors, but the only resistance is this light bulb right here. And I got two of them going right now. Each of them are charging one of these batteries respectively. There we go. So that one did have like a moment when I hooked up the previous relay where there was a voltage drop, and I think it was bleeding through a faulty transistor, but the voltage went down to like 12.6, and I was like, oh no. Just like really fast. I was like, damn, what just happened? So I gotta figure all that out before I hook it up again. So 1, 3, 4. You can kind of count each jumper cable representing the 1, the 3, and the 4. You got your light bulb, your transistor, and your coil. Then you got your charge battery and your drive battery underneath there. And I think it's awesome because the 1, 2, 3 didn't have the output. And now it does. Now it's a more complete circuit. You got your generation and your your speed, your motor. Awesome. Now, I think the only place that it can improve is to perfect the coil. But it's work for just an air coil. I think that's phenomenal. That's like truly amazing how fast that's going up for an air coil. I think anyway, and I've been doing just charging batteries for a few days now. But this is the first time I've actually done the expansion on the 1, 2, 3 to make it 1, 3, 4 and charge a battery with it, and I'm impressed. So let me explain what happens here. It basically, the circuit takes the electricity it needs to run, and then this branch off with the diode on it comes right off the collector. So it's basically coming straight off this battery minus whatever this takes to run. And that, minus that, and then it goes onward to the battery. And then you just have to ground your battery to the emitter. I tried grounding it straight to the ground of the battery, but it's got to go through the emitter for some reason. I don't know why. Because it didn't charge when I had it going through, when I had it connected to this little wire right here, going in, and then the grounded wire is right there. So it has this double split. So I don't know. But it does work and charge and all the above when you ground it through the emitter of the transistor. So that made 4 on the emitter, and 3 is this one right here. Awesome. So I figured I'd just stick with the numbers, and the BCE transistor, uh, base, collector, emitter, in like that order from left to right. It's usually the best one to use with this circuit. It could be any variation, like any number, right? Here, let me see if I can read off the name of the transistor that I'm using. Sometimes it's really light. The 2SC5200 from Toshiba. Really nice transistor. Goes really well with this circuit. I believe it has amplification properties. Very nice. So it doesn't have to run very long to charge the battery. Now let's see how much backlash we get, how far it goes down. Yeah, it's cool, man. And then I put the switch on the negative side. So that's how I was taught how to do the switches. You got to put it on the negative side. And I mean, it only makes sense to put your toggle switch in the circuit. So you just want to connect one end to the end of the coil and the other end to the ground, and just, have it for safety purposes. I think it's really cool. It's so easy. I mean, once you get the dots connected correctly, it's like really easy to understand. And you should read it as in you're connecting the dots. You gotta connect the dots, or it doesn't make sense. And when you think about it and then connect the dots, you're like, man, I used to play that game when I was in second grade. I'll connect the dots. But seriously, if you look at it like that, you can't mess it up. It's like, and I see where there might be a flaw in the understanding. Like right here, this is a connection point, there's no dot. But I just kept all the dots to represent the 1, the 3, and the 4. But, if I need to put dots on the connection points, I can do that. Absolutely. But the first time I learned about how to set this up was from a guy named Peter Hall Effect, Coil. I believe he's X or 10, Peter Hall Effect 10, which is the Roman numeral 10. And yeah, he broke this down to me for the first time about a year and a half ago. And I think it's awesome, and I think I need to share it. So yeah, giving credit to him for teaching me how to do this so that I might be able to teach other people how to do it. Getting tremendous output from these little tiny coils. I mean, it's great. It's literally, well, see, the thing about turns is if you start with a 3/8 axle, um, your turns are going to be a lot smaller when they start out. So that's 450 turns of 24 and 32 with an axle of about an inch. So it's a pretty big turn to start out. So it's, it looks smaller than, say, another coil or a different size coil. Trying to look for an example real quick. Right here. This here is 850 turns of 32, 32, and 24. But when you compare the two, it's like that looks like way, it doesn't look right. But it's because of the axle in the middle. It's part of the formula to figure out how many turns is going to be in your coil. But I don't know that formula. But it is part of the formula of the size of the axle. So I was just getting my batteries up to snuff. And then I'm going to attempt to do a relay where positioning is key. So when it's hitting this magnet, electron magnet, the other one is off. And when it spins, it's hitting this one, the other one is off. So with that mechanism, I can relay batteries without actually needing a relay. It's awesome. We're going to call it I believe it's called the Bedini bounce. However, I'm not using Bedini circuits. I mean, they're close, but there's no resistance. There's no resistors. Which I believe is one reason why the generation is so good, because there's no resistance, added resistance. But what I would do for resistance is use a coil instead of a resistor, and just use a coil that has a specified amount of ohms. Put it in series with whatever you need resistance on, and it's good to go. Just adding length, basically. And it works, man. Sometimes it works better than a resistor. Like better than it would if you just used a resistor. But I don't know. I like trying to do things a little bit differently. And this relay is going to be awesome, you know, if I can get it to work without burning everything up. Yeah, I had a short go through one of my Bedini circuits when I hooked that relay up just earlier this morning. Lots of smoke. And it was, let me think here, the output negative and the input positive got connected somehow when I clipped it to the battery. All right, so let's turn it on again. We're going to start by spinning it. It's just that the batteries are kind of charged up, so I mean, I can't just keep charging the charged up battery. Maybe I can, I don't know. I don't like to like push limits like that because it's not cheap. Something goes wrong. It didn't show. Oh man, that's rough. So I'm gonna unhook that one. Oh wow. Yeah, that one's pretty charged up as well. Yeah. So that's pretty awesome. Yeah, they were down to like 12.5 earlier today. Oh, oh man, I feel so good. The circuit is pretty gold. I mean, it could probably go faster with some resistance, but it's charging very well and doing things very well without resistance. Get down. Kegs, get down. I just don't want them to get singed or, you know, whatever. So it's the 134 now. I don't think we're going back to the 123 because that just wouldn't make sense. So it's the BCE 134. And there's all your connections from the transmitter or transistor, my bad, to the battery, primary battery, charge battery, coil, and light bulb. Without any extra writing or anything like that, just primary charge. I mean, it could probably do with a few simple explanations, but that's basically it. This is a transistor. So I mean, it charges at a pretty good rate. Let me get a tach reading on how fast. So about 1500 RPMs. Air core. I don't have any core in these, and it's still doing pretty dang good. I mean, it probably would be faster with a core, but then I don't know. I don't think I'm going to use a core. And what we're going to set up here is a relay where we use alternating batteries right here to charge and drive relay, positional relay. All right, so I'm going to throw this back up in. Here, maybe we'll get a cameo or something. All right. That appears. Oh no, that's the other battery. All right. So we're both batteries are up to 13 volts, which is awesome. Oh man. I mean, if I was gonna make a core for those coils, man, it would be a really fat core. I don't think it would. I think the attraction of the core would prevent the motor from working properly. Because it's bigger than half the size of the coil. I mean, there's basically the same amount of material, copper and iron or whatever you would use. All right, so if somebody can tell me why my circuit shorted earlier today, it went through, when I was hooking up the Bedini bounce, it went through the, let me show you. So it went the positive side of the input and the negative side of the output got connected and shorted out. I believe it was the batteries obviously got connected through the circuit. And there was lots of smoke and but I'm going to try again with these circuits. I don't know what will happen. I'm hoping the same thing does not happen. So this is the circuit that I'm using currently. It's basically just primary drives the coil charges the secondary through the collector, and everything's grounded in the emitter. And then of course your trigger coil is connected to your base and grounded in the emitter. And that's basically all the connections that are there. You got your light bulb. And currently there's not enough energy going through the circuit for the light bulb to really light up. I think these are phenomenally low cost coils, so that's good, especially considering the rate at which they're charging at. So it's a totally battery operated system, which is good. I'm pretty sure that running the Bedini bounce is going to work. Or I'm just calling it the Bedini bounce because I was going to use Bedini circuits, but now I'm using collaborative circuit. Trying to keep it as simple as possible. I don't know. I might throw a pot in each one just to see like if it would help. And I'm also looking at the output rate when I'm using the pot too. Like both of those things have to, either balance out or go up. Man, I want to set it up right now, but I'm going to have to charge up this multimeter. There's lots of things I need to do before I can hook it up. Maybe I'll use this one. That one went down to 12.95, so. So 13 and 12.95. Wow, dude. That's awesome. Excuse me. All right, so just a few reconnects on to remove the base battery and change the dry battery into alternating SLAs. Hey, what's up, man? Hey, Peter. Man, your circuit, the one you taught me, is really smoking, man. It's gonna break records. Heck yeah. I mean, just look at the size of these coils, man. I'm generating at pretty phenomenal rate. Like if I got some real coils on there. Oh man. So how you been? I think I've seen some stuff reminiscent of the last time we talked. You were talking about shorting coils. I've seen a lot of shorting work going on. Research, yeah, shorting coils, exactly. Over Unity Research Channel showed me his latest shorting circuit that he's doing. It's pretty cool. And then the force charge, I believe is what it's called. Force charging. So I've been trying all different kinds of coils, trying to find one that's cheap to run, but at the same time will generate enough. Generate enough. That's how I'm going to put it. So you got your standard connection, one to the base, to the trigger, and then you got your output connected with that. So it's 134 instead of 123, and that's what I've been calling that circuit, the 123, just because it's in its rawest form. That's what it should be. You know, you got your light, and then you've got your across your collector and your emitter. You got your trigger, and then you got your coil. You got your power. And then yeah, everybody's doing stuff, and it's great, man. I like it a lot. Now's the time to shine. Alright, so before I start the relay, I need to ask somebody some questions about it and make sure that I'm not like burning stuff up. That's awesome, man. Heck yeah. Heck yeah, dude. Hell yeah. 1-2 cents a day? Wow, dude. Oh man. Heck yeah, I'd keep it on a DL myself. That's awesome. Uh, mind at me asking what uh, is the main component in that? Or what would you consider the main component in reducing your bill? Wow, dude, that's amazing. So, is it a homemade transformer or did you get it? Was it pre-made? Oh, okay. Of course. Yeah, those are nice. I don't know. Maybe that could run everything that I have on. I'm not sure. I know that it would definitely be a help. But I have a lot of stuff on right now. Like the TV is on, my monitor is on, my computer is on. I don't know. Okay. Cool, man. That's awesome. So like all your lights, your laptop or your computer, that's awesome. And that's 1 to 7 volts, you said? That's that's brilliant. So I've done 2 types of relays in the past 2 weeks. I did a Bedini bounce on the other day, but I had a voltage drop that I can't explain, and I would need somebody to explain that to me. And then I did a timed relay, and both of those were awesome. I mean, the spin and gen rate were pretty equal. Now, what would be awesome, and what I've been thinking about a lot, you have your Tesla coil, which is basically a transmitter, right? It sends a frequency, a resonant frequency, outwards from the coil, or from the wire, or the center rod. It's a transmitter of frequency and resonance. Now we need to make a receiver that can work with the hot end of things and the cold end of things, and start combining. Okay. You've built it? cool. So you have experience with this then. That's why I'm using the little ones, because they're exactly the same. Oh, I see what you're saying about the, oh, okay. Are you talking about the Bedini bounce, or are you talking about, wireless reception? Oh, okay, yeah, yeah, man. So you built, what I'm getting at is having the one Tesla coil as a transmitter, and then having the other one as a receiver that will run my pulse motor. Without any like crazy loss or anything. Okay. So it's got to have a nice axle. Okay. Yeah. And then just like the one wire connection, you just touch that wire to various other materials, and it turns into basically the Tesla coil. And it appears to be a transference of resonance from the Tesla coil to whatever he touches the rod to. But really, all you got to do is connect a wire to the rod, and then you just got to touch the wire to whatever it is you want to change. I was watching. Good, good. That's awesome. That's what I want. That's good. That's exactly. And then I was thinking about having a bunch of mini, like smaller Tesla coils, uh, and solar roadways, and build Tesla coils into our infrastructure. Like as if you need funding to build the Tesla coils into the infrastructure, you put it under infrastructure, and then you use the infrastructure money to build that stuff. Yeah, it's a much more efficient way, I believe, to transmit electrical energy. But oh, sweet, dude. How did that's awesome. Yeah, so yeah, Tesla coil is I have yet to champion one of those. And this is the only pipe I have right now, but I need to, I need to get the proper stuff. Yep, 3 inch and 4 inch, right? Okay. How tall? How tall does it need to be? Like a foot? Yep. Yep, I can do that. But it can only be 8 inches high with my 3D printer. Yeah, I'd have to print it in a bunch of different sections. Hey, Tiggs. But the idea is to have them be the same size, have the two be the same size, so they can communicate with each other better. Yeah, like the base of it. Yeah, I know Old Man Builds. I joined his channel, and I joined Ben's channel too. I watch quite a bit of both of their things. But yeah, man, like getting a good receiver that will turn that energy into usable for a hot circuit, not just a cold one. Oh, for the primary, yeah, that's a shorter piece. Yeah, I could do that, sure. So yeah, the secondary, but it's all the you know what I'm trying to say, all the soldering, man. I can't do that. There's nowhere for me to do that. It's frustrating. All right, sweet, man. Okay. Now, this is the one thing that I hate. Like, there was two of these. There were two of these on the picture, and they sent me one for $20. Yeah, you know it, man. The picture had two, but it didn't say there was two with it. So they just, yeah, they clickbait you. But yeah, the ZVS. And then I was supposed to change out the capacitors with the ZVS with this. Two of these actually. Damn. And it took like 3 weeks for them to mail it to me too. So I got the ZVS driver. So I got the ZVS already. I mean, as soon as I learned like what to do, I jumped on it. But I make a lot of moves before I have all the data. Yeah, this is the dual inductor. It's a nice one. It's got the 6 capacitors. Oh man, I followed Nathan had a specific one that he was using, and I tried to match it the best with what he was using. He said use the one with the 6 capacitors. So that's the one that I got. Okay. Yeah, man. Uh, that's so cool. I know you've been doing something, and it's Tesla coils. That's cool, man. Yeah, I want to see about how big I need to make it. I mean, you told me all the, but I want to see it. You know. Hey, all right. So, and I love how this thing just loves to move. It's still moving, and I turned it off like half an hour ago. Yeah, sure. You want the G codes for which rotor? Are you at? What do you? I'm confused. Which one do you need? Do you want a 4, a 6, a 2? I'm working with 2 right now. You want a 6? Okay. You want it to be made for, like, we'd have to talk about it, like which magnet type. Cube magnet, big magnet, small magnet. Yeah. Yeah, we need to talk that one out because there's a lot of options there. But you want to 3D print it on your 3D printer, and that's cool. Okay, so are you looking for? Yeah, we'll have to talk about it, like a toroidal or. Okay. So what I'm looking to do is I'm looking to set up these coils in a Bedini bounce and run a relay or a battery swap with these circuits. Just that's one thing that I'm looking to do. Yeah. So you want? Okay. Yeah. I had a, what do you call it? A counter rotator that was kind of like that. It's a simple version of that. Blue one had the coils in the middle and the magnets on the outside. So are you talking about bifilar coils? Uh, 1-to-1 bifilers? Because reed switches, you could do that. You know, you could have the open one go one way and the closed one go the other way in the same coil. And then you could time it. I kind of see what you're saying. Like, if I only look at it from a 6 uh, interaction point of view, how many magnets were you planning on having on the outside? Okay. Oh man. See, now we're getting. I have a buddy that might be able to do this better justice than I could do it, but I'll give it a shot. Yeah, so what you want is the ability to move the coil away from the center. So you want a reed switch, an open reed switch on the exit of the coil, and you want a closed reed switch on the entrance of the coil. Right, right. Um, sure. Uh, gotcha. Yeah, you get a lot of power from that. And I've been doing, a lot of experimenting with the counter rotating devices, and you got to time it really well for it to you get the double output. See, now you say that, and I got it right out there, and I can stabilize the magnets. Well, yeah, at what speed does it bend space time, or does it not matter? But yeah, I could definitely vibe with that. Let me get the thing in question here, because I might even be able to do some of that like right now. Now you're talking about shorting the coil back into the coil, correct? Like back into the drive. I mean, those coils can't move, but is that kind of what you're talking about? Having the rotor with the, yeah, yeah, I get it. But like, so do you want like instead of six, we do three and have it be like the flux capacitor? And then we just solidify this on the outside here. And then you got your three magnets. I want to try that. The reed switch, open close reed switch is going to be really important. And maybe you could draw me the schematic of whether or not you need bifilar coils. But you're just looking for the shafts, right? It doesn't, that's not important. But we could talk about it anyway. You just want the ability to move these back and forth if you wanted to. All right. So, I mean, So this is on some commutator plates and two donut magnets. So it's maglev. It's got a big reed switch. But that what you were talking about with the reed switches is really what's interesting to me. To short the coil and to push at the same time, or is it to be like juxtaposed, or one at a time? Well, I don't know. You'll show me. But you want one of the ones that goes both ways, right? Open and closed, and then you hook up both ways. Because they actually, they come in open and closed variations, right? And then maybe you could use both variations if you timed it right. I don't know. Oh, I see what you're saying. Yeah, I gotcha. Reed switch on every coil. Nice. Yeah, and when you got the two reed switches, does it matter if they're open or closed? So one, when the magnet passes, it'll open up, and the other, when the magnet passes, it'll close. Well, you want normally open, right? Just a standard reed switch. Okay. Yeah, and you're getting your power from the short, right? And the magnet passing. And it normally closed. So when the magnet passes, it'll close and short the coil. Ah, so you're talking about putting a reed switch right here on each coil. Right. Okay. And then you're based on what you're saying, it should work just from you spinning it. All right, so now we're putting it in the front across the center hole, so it's going horizontal. Yes? All right, sweet. Hello, Society of High Sciences. What's up? What's up? What's up? Gonna do a Bedini bounce on that rotor right there. You made a Bedini bounce already? the flux capacitor. Ah ha ha, thank you. Glad you made it. Now, what I'm doing here is called a Bedini bounce, and it's virtually a relay without relays. Now, there's a few more things I need to get taken care of before I can actually put it into action, but it works pretty well, especially with these little coils. The gen rate's pretty high considering there's no added resistance. This is the circuit that I'm working with right now. Peter, Hall Effect X there, he taught me this circuit right here. We're gonna pan out all the way. There we go. Sorry about that. All right. So, the diameter of the rotor, sir. The max I can make is 8 inches. Well, I'm looking for equivocal amounts of, since these coils are really cheap to run, and they generate a decent amount of power, that's kind of what I'm looking for. And they generate pretty nice. I mean, they're pretty equal right now. And they're generating pretty quickly as well. And they're literally the only two coils I have that are exactly the same. Maybe not 100%, but 95%. It's a pretty high conversion rate. No, I don't know the exact percentage, but I got a good idea because I ran the coils on the power supply, and the max draw was like 170 milliamps. And it's clipping, man. It's going like 1500 RPMs at 170 milliamps. Yeah, 3000. So that's 1500. What do you think I could do to improve it? Yeah, I've eliminated everything except the light bulb because it likes the light bulb. I use no resistance in the circuit, but we've tried to incorporate resistance somewhere along the line at different points in time, but this is the best. Okay. What about a magnetic? I don't even know if I could use a magnetic bearing on this particular build because the shaft is static. The shaft doesn't spin. Spin it on the shaft. Yeah, but I don't vape, so I don't do any kind of nicotine or anything like that. Well, I don't vape, but I guess I could. My brother does. I guess I could get some batteries from him. Ah, cool. Yeah, but can I use a magnetic bearing without a moving shaft, without a spinning shaft? Because I think the magnetic bearing goes on the shaft, doesn't it? Yeah, when I started out, like way back when, I I like as fixed my rotor to the shaft, and the shaft was spinning with the rotor, and that way was like just as good as not doing it that way or doing it the way I do now. But now I see a bunch more like advantages. Like you could put a fan on the shaft if the shaft is spinning, and then it would spin. You could do some torque tests, but without the shaft spinning with the rotor, you're limited like tremendously, in my opinion, because you're really not supposed to put stuff on the rotor. Uh, but I go against that philosophy all the time, man. I put lots of different things on the rotor. Yeah, but I mean it's off now. I turned both circuits off. I think it has somewhat okay flywheel capabilities, like forces kick into play once it gets going a certain speed. There's two magnets in the rotor, and there are two square divots where other magnets could go that are definitely dragging some air. Uh, so I could like put something inside of those if I really wanted to get down and dirty about it and like prevent air draft from that. This is actually a really, really, really good design for lack of draft catching. It's all the way around, but I made this rotor before um, they changed the amount of sides you could do for the circles in Tinkercad. So it's 64 sides to that circle instead of 128. So yeah, just that alone makes it a little bit more less of a circle. But not having cores has actually been a blessing in disguise. I know that having a core would increase generation and but it just wouldn't make sense. If I put a core in these coils, there'd be more core material than there would be copper. And I don't think that would function very well. But I don't know for like certainty how well it would function. Well, you don't necessarily need a flywheel in space. You could have anything in space and you spin it because there's no weight in space. But yeah, there'd be, I mean, it would keep going because there's no friction. I mean, it would keep going until it hits something. Yeah. The only thing about these lights, though, is that when I turn on with these coils, I get no response from the lights. And they're hooked up perfectly. Yeah. And I found that the light bulbs with the filaments in them provide more resistance. So, like what I was saying, I don't have any added resistance except the light bulb. And there's filament in the light bulb, so there's definitely some added resistance, about 50 ohms. Uh, and then the light, well, yeah, that's basically what it is. Well, the fan, I wish I could use a fan, that would keep it cool in here. Yes, lens effect. I haven't like overcome lens, but you can see that I just spun it with my finger. It's still going. So I've minimized it by backing the coils off a little bit. I haven't overcome it, but I'd say I've minimized it. Yes. Any power drain on the system will immediately affect how fast the rotor's going, which will immediately affect how much power you're generating, so on and so forth. But, you know, it's still at 12 volts. It's overcome whatever it is. Alright, we gave it a little boost, shut it down. So, I mean, that its level out rate is actually 1500 RPMs. So yeah, gonna make a couple of Tesla coils. Got my ZVS. Right here. Nice heat sinks on this thing, man. Wow. All right. And then I got one of the two capacitors that I need. These little bad boys. I got one of these. I need two. But I still have to build the coil. You know, there's lots of things I need to do. Now, the Bedini bounce works because of the two magnets at 180 degrees and the two coils at 90 degrees. But what I was thinking is you got these two empty spaces right here that you can utilize because there's two magnets. Okay, so you could have one over here that's doing nothing but generating for the battery that this one's charging. And you just dump them down the same chute. And so I made this coil, which is 12,000 turns of 32 gauge. It's a trifilar coil. It's 12,000 turns altogether. And it's in parallel. It generates probably 53 volts of DC or AC electricity up against this rotor. So that's another 50 or so volts of DC that can be pumped into the generation. So I mean, I don't see why it wouldn't work. I don't see why you can't have a coil right here that's working in tandem with this one. So it'd have to be very well timed or positioned, I should say. All right. So what I asked Nathan about was if any coil could be brought into a resonant frequency. So I'm like, can this coil do it? He said, yes, any coil. So I got a signal generator and I want to kind of find out what the resonant frequency of this fat 20 gauge coil is. Because resonance removes impedance, and impedance is not good, I guess. I think it is good for moving magnets though, so I'm not exactly sure, but we're going to try it. But I'm like, I tried to remember because I had the 1, 2, 3 circuit, which runs stuff awesomely. I'm like, doesn't this have a generator side to it too? And then I try to remember what it was. And I'm like, yeah, you just stick a diode off the collector and you attach that to whatever you want to charge, run, whatever. And then you ground it to the common ground, which is the emitter of your original transistor. I was like, yes, that's a win. But that is Hall Effect X, Hall Effect 10, Roman numeral 10. It's awesome. And what it was is I was trying to look for a breakdown of the SSG step by step, and he was trying to do it for me. And there was like some parts of it that I didn't understand, like where to put resistors and certain diodes. And this is kind of what I got out of our discussion. And it works, man. It works wonders. And it's not SSG. It's close. All right. Well, this is cool. So I need to find out what that connection. It's like the juice from one battery forced itself into the other battery and it shorted out my circuit. When I was doing my Bedini bounce earlier, so I'm hoping that with these two circuits, it's not going to happen. But I'd like to put it more than just hope. You know, I don't want to just hope it into existence. I want to know. So I'll keep asking questions. So my grandfather got this when he was traveling in Egypt. So this is a true Egyptian souvenir. It is a souvenir. It's made out of brass. With the high copper content, you can see where it's starting to oxidize, but only in like certain spots. Now, if I flip it over and I do the same thing, totally different sound. So, I mean, the shape of this is totally part of what it does. Okay, it's awesome. All right. Whew. We're going to wrap it up here in just a little bit. Next one, we're going to be doing a relay. So let's just turn it on real quick. And I'll be wearing my lab coat next time. It's kind of a red and black leather duster, but you know, it's the closest thing I got to a lab coat. And it takes 2 coils on separate power supplies to get it going 1500. So it's not like they're the most powerful coils in the universe. But I think they're right about where they need to be. That's awesome. Just at the rate that it's generating, I don't know honestly how long, how like comparative they are, like the spending and the generating, but I like what I'm seeing on these meters. And there's not really a place. I mean, I could probably add another jumper wire and try and connect to the coil that way to see how much is being spent from this battery. But it's pretty airtight. It's pretty closed up. You want to keep both batteries around 13 volts. So tons of stuff to work on now. Lots of stuff to do. So I'm excited. And I'm gonna call it for the day. Give my throat a break. Thank you very much, ladies and gentlemen. Peace out. Have a wonderful day. Please subscribe, join, help out, give a shout out, and peace out. Bye now.